Okay, hi, good evening. My name is Muhammad Arfan bin Muhammad Azni. Metric number S49221. So today I'm going to present to you about how to make thin film or the process of making thin film. Okay, going on the first point. There are generally three steps in making thin film. So the first step is the emission of particle from the source. The second one is transport of particle towards the substrate, and last but not least, the condensation of particles to the substrate. This diagram shows you the process of making thin film using evaporator. So in the first step, a material is vaporized and released. When the material is vaporized, particles were released. So that is the first step. When the particles was released, the particles will move towards a substrate. So from here to here, it is the second step. When it has reached the substrate, it will undergo condensation with the targeted subject. So this is the process to coat an object. Okay. Going on to the next point. All right. For the step one, the emission of particles from source can use many types of source, but in this presentation, I present to you three different examples. So the first one is by heating, just like the previous slide, where a material is vaporized. The second one is through using high voltage, where uh, an element will be supplied with a high voltage. When the high voltage was applied, the element will release a gas in the form of plasma. So the plasma will travel towards the substrate. Yeah, in this diagram. And last but not least, using laser. Emission of particles can be used using laser, which is focused into an element. An element will, the atoms in the element will gain enough energy by which was transferred by photon from the lasers. The energy will cause the element to release plasma. So the plasma will also travel towards the substrate to perform thin film process. Okay, next. Okay, step 2 and step 3. Like I said just now, the second step is the transport of particle towards the substrate, and the third step is the condensation of particles on substrate. Okay, so the condensation of particles towards the substrate consists of um, many more process, which I will explain later. So this diagram shows you the both of these steps. The second step is right here, where the journey of the particles start from its emission. The journey from its original place towards the substrate is the second step, which is the transport of particle. And the third step generally is over here. The absorption, desorption, adsorption, and surface diffusion is all condensation of particles towards the substrate. In other words, it is the process of combining the emitted particles with the substrate. Next, all right. Okay. After to make the process of condensation, I'm sorry. When making thin film, it must be growth. So the steps of film growth is start from its when it is arrived at the substrate. So they generally contains 6 steps. The first is absorption of physisorption. The second one is surface diffusion. The third one is chemical bond formation or chemisorption. The fourth is nucleation and growth, which has many types, and I will explain later also. And then the macrostructure formation, last but not least, the bulk changes. So in this diagram, it shows you the process of the steps of film growth. So when a particle, you imagine there's a particle from an emission, it comes here, this is the substrate, comes here, and it will undergo 6 steps, that which is this one, the steps. This number um, uh, represents the steps that I speak to you earlier. Since yeah, right. Okay, okay. Before we go on further, we must know the difference between physisorption and chemisorption. So, physisorption is an approaching atom. Okay, so physisorption is like an uh when when a particle arrive at a surface, at surface. So the process of the particle to merge with the surface is physisorption. Okay, so it can be the particles can be reflected or absorbed. So it's not uh, I call melekat. Sorry, it cannot stick it is not strongly attached. Yes, while chemisorption is the absorption in which the absorbed substance is held by chemical bond. So when it is held by a chemical bond, it will hold tighter. So imagine if you have a sponge, and you have a sponge and spoon. When you put it, the spoon cannot go through the sponge. It will just uh, touch or release, touch or release. So that is physisorption. But imagine you have sponge and water or any liquid. You put liquid on the sponge, the liquid will absorb into the sponge. So that is chemisorption. It will be uh, cold chemically and more stronger than physisorption. You can see it in this diagram where the particles can be absorbed or dissolved. For physisorption and chemisorption, the particles has already get inside the substrate. Alright, moving on. Okay, so for the steps of film growth, the first step is physisorption, which I mentioned earlier, when any particles arrive at a substrate, so it want to attach with the substrate. It will undergo physisorption. During this stage, it can be absorbed or rejected. Any particle can be absorbed or rejected. Alright. So next one is surface diffusion. Surface diffusion is overall surface energy can be minimized if the atom has enough energy and the time to diffuse to a low energy state. The diffusion rate increase with temperature. So the higher the temperature, the higher the diffusion rate. It is easier for a particle to diffuse with a surface when it is high in temperature. So that is why many chemical process, for example, to catalyze something, if you want to activate something, you must heat it first. So the surface diffusion is more likely, and the process can undergo easily. Okay, next is the chemical bonding. Okay, once an atom sticks to the surface, it creates a tension energy in the surface. It is due to the surface atom stretching their bonds in response to the absorption of the atom. Okay. Alright, so moving on to the next step. Okay, nucleation and growth. So, nucleation and growth in thin films consists of a few types, and I will explain to you 3 types of it. Okay, this is basically the nucleation and growth, the examples. So you can see nucleation seed become aggregation of nucleation seed, and then it will form a nanostructure. A pillar come from one source. So you imagine a coin, and then some it will the particles grow from here and make a pole. So that is the first example. And lastly it will become like this. The second example is when you have one surface, the nucleation seed is here, and when particles have arrived at the substrate and undergo surface diffusion and chemical absorption, it will form a pillar, but upwards, not in all direction. The first one is in all direction. The second one is only upwards. So it will become like this. So in the next slide, okay, nucleation and growth. Okay, fast nucleation will results in the small nanoparticle growth, while slow nucleation will creates large nanoparticle. So the slower, okay, this is the particles that have arrived at the substrate. When the faster the particles arrive at the substrate, it will perform I'm sorry, fast the faster the rate of the particles arrive at the substrate, it will create small nanoparticle. So imagine like sorry, like this pillar right here. The faster the particle arrive at the substrate, the smaller this pole will be. The smaller the tiang, yes, the pole will be. So if it is arrived with a slower rate, it will become larger. So basically, when it's fast, it will become small but tall. If it is slow, it will become tall also but larger. Okay. All right. So this is the three types of nucleation and growth. The first one is Volmer-Weber. The second one is Frank van der Merwe. And the last one is Transky-Krastanov. I will tell you the details about the three of this growth of thin films. Okay, the first one is Volmer-Weber, or aka island growth. Okay. The 3 points of this growth is the material balls up to minimize interface with the substrate. It will perform uneven growth where it is randomly and not smooth, and it is a slow diffusion. Okay, like I said just now, slow diffusion. Okay, slow diffusion. I'm sorry. Okay, so as you can see, the thin film has what a mountains like structure right here, because this is a Volmer-Weber or island growth, which means the particle arrive at one surface one by one, and when there is one hill, another particles continue to be collected at that hill. So when many hills, and you become like this, it will not become a good thin film, as it will cause the structure to be not smooth. Right. The second one is Frank van der Merwe, or layer by layer growth. Okay, this is a good process because it will form a smooth film. It is a layer by layer growth, which means if you imagine a paper, it will become the process of condensation of particles to the substrate will be one layer, and then another layer, and another layer. It is smooth and will not have mountain range, just like Volmer-Weber. Okay. The film wets the surface to lower surface energy. So this is the good process for making thin film, because a perfect thin film will have a very smooth surface. So As a matter of fact, if you know Hubble telescope is the biggest telescope has been sent by the humans to space. So the first try of Hubble telescope, the picture is blurred because the surface of the uh, lens at the telescope is not is not smooth. So the project was considered to be failed because it must be uh, because the picture taken was not clear. So the telescope was repaired, and yes, we can get to see the universe as we know it today. So it is important to have a smooth thin film. That is just an example. Yeah. Okay. Last but not least is the Stransky Krasanov or mixed growth. This is the same with the previous two, but it is the combination of the previous two. So imagine you have layer by layer Frank van der Merwe growth, and then suddenly you have shillings to represent the Vollmer Weber growth, one by one by one by one. So this is the combination of the two earlier growth. This is, even though it is has initially a smooth surface, but when it has island growth, it is not good for the thin film technology. Alright, moving on. Okay, microstructure formation. This is the fifth step of the nuclear growth. Okay, there are three classification of materials based on structure. The first one is crystalline. The second one is single crystal. Last but not least is the grains. Okay, crystalline material is a material comprised of one or many crystal. So you can imagine there are a few types of shilling in here. 20 cents is one crystal, 10 cents is one crystal, and 50 cents is another crystal. So we have three types of crystal. So when we have many crystal in here, this is crystalline material because it consists of many crystal. So that is the example. One single crystal, sorry. Okay, one single crystal is when there are only one type of shillings. You can imagine if there is only one type of shilling with for example 50 cents, so that is single crystal. Okay, grains are the crystal in a polycrystalline material. Okay. Okay, as you can see, there are three types of shapes here: the crystalline, polycrystalline, and amorphous. So in crystalline, there are what we call same structure all the way from the up to the bottom, while polycrystalline have the same structure but in certain part of the crystal. Amorphous, however, is not same at all, but it still have patterns in it. Okay. This is because polycrystalline crystal consists of many crystals. So in here there are many crystals, just like I said just now. It has 50 cent and 20 cent and 10 cent. So one part is 50 cent, one part is 10 cent, and another part is 20 cents. Alright. While amorphous, it was too random, but there are still patterns in it because it is non-crystalline. Okay. Okay. Last but not least, the process of nucleation growth is the bulk changes. The bulk changes, as you can see here, A is the intragrain, the B is grain boundary, which is the here B. Let's imagine this is intragrain. A is intragrain. Okay, there are two intragrain. So the line between two intragrain is the grain boundary. Okay, so this is what happened when a thin film has layer by layer. So the last process is the bulk changes. All right, grain boundary energy is responsible for grain growth on heating. Uh, okay, large grain grows at the expense of smaller one. Okay, grain. All right. So if you heat a thin film will grow evenly. I mean, if you imagine there are two part, this will grow and this will grow also. Not only this grow, both will grow. So the area will grow, the length will grow, the length will grow. So it will become larger and larger together. Okay. The growth is based on heating. So the higher the temperature, the larger it will become. Okay, so this is one of the example of bulk changes. The first, this there are four particles, and then when it has gone into touch, it will combine and combine, and it will become almost like one particle, but consists of four particles. Right. All right. That's it for my presentation. Thank you.